Today we will discuss about the voltage built up in self-excited generators. As we know that in DC machines, generators, if separately excited generator is there, then there is field winding is separately from the armature winding, so that both are separate. So field winding is excited from the external supply voltage of DC, so there is no problem of the voltage built up in separately excited generators. But in self-excited generators, because of field winding and the armature winding, both are connected either series or shunt. So that case like this. So this type of case, when both a voltage supplied to the field winding and the armature winding and both are connected to the same circuit, so there is a requirement of voltage built up in the shunt generator. So we can assume that if shunt generator is there, the supply voltage is VDC, the field current is, the armature current is coming from this generator is IA, and field current is going IF, and that is the voltage that is called line current. So again we will see here like this diagram. Suppose so this is the shunt generator at no load condition, where IL is equal to 0. So there is a field current IF, this is the RF resistance, this is the RA armature resistance, and this is the voltage developed in the armature of DC generator. So voltage buildup is done by using the flashover voltage, a little voltage at starting to the circuit, so that it will having a residual magnetism in the circuit. So that's why we can say Eg is proportional to phi omega m. So Eg is, we can take a constant phi residual into omega m. So small voltage of Eg is equal to 1 or 2 voltage will be enough for build up the voltage in the shunt generator. So we know that the field current is equal to V upon RF. So now we can understand that when we are giving small voltage 1 or 2 voltage, then Eg is increased. As Eg is increased, phi is also increased. As phi is increased, so IF will be increased, and again because of IF is increased, the voltage, terminal voltage is also increased. From this relation we can say IF is proportional to V, and also we know Eg is equal to Vt plus Ia Ra. So as V is increased, so Eg is further increased. So that is a cumulative process of voltage buildup in DC shunt generator. Now we can understand from this graph this characteristic of this voltage buildup phenomena. So the x-axis is a field current IF, and y-axis is the generated voltage Eg. So from this characteristic we can say the 1 or 2 voltage start from here, point is P, this is original point O. So we can understand here when OP is a 1 or 2 voltage, because of this the current is increased field in direction of X. So we are getting the point of Q. Again because of field current is increased, so V is increased. As V is increased, So we can understand here that Eg is also increased. So that point will extend towards the above point. Similarly, again Eg is increased, so field current is increased. That is a cumulative process. We are getting another point like this. So same type of point we will get here. So these are points which we are getting from these characteristics, and when we join of this characteristic, we will get like this type of curve, and that is called as a voltage buildup phenomena characteristic of DC shunt generator or self-excited DC generator. So this way the voltage is increased in the DC series shunt generator as the field current is increased, and that is a cumulative process. So this is all about the voltage buildup phenomena in self-excited DC generator. Thank you.